When you're solving a radical equation, you want to isolate the radicand. So I'm going to first add 10 to each side. So I'm going to square root of 2x plus 1 equals add 10 to have 5. Then to get rid of the square root, I'm going to square both sides. So I have 2x plus 1 equals 25. So x equals 12. So on letter B, it's already isolated, so I'm going to square both sides. Squaring and square rooting are inverses. So I have 3x plus 4 equals 16. Then I have 3x equals 12, so x equals 4. And you can plug them back in to check to see if they work. And then over here, this negative 2 is not underneath the square root, so I'm going to add 2 to each side. So I'm going to have the square root of 6 minus 3x equals 2. And then once I square both sides, I'm going to have 6 minus 3x equals 4. And then I'm going to end up with x equals 2/3. So just like you've done square roots like a, b, and c before in Algebra 1. But in Algebra 2 we've done rational exponents, so it's not just going to be x to the 1/2 power. Like the square root is x to the 1/2 power. Now we have different rational exponents. So the same thing goes where you want to isolate it. So I'm going to divide by 3 first and get x plus 1 to the 3/5 equals 8. So to get rid of the 3/5 exponent, what I'm going to do is I'm going to exponentiate both sides to the inverse, the multiplicative inverse of 3/5, which is 5/3. So the 3/5 and 5/3 are going to cancel out. So I'm going to have x plus 1 equals, now 8 to the 5/3 is the same thing as the cube root of 8, because remember this is the root part, and then take that to the 5th power. So the cube root of 8 is 2. 2 to the 5th power is 32. So subtract 1, you get x equals 31. And then letter B, I'm going to isolate by dividing by 4 to get 2. Now to get rid of the 1/3 power, you're going to exponentiate both sides to the power of 3. So the 1/3 and the 3 cancels out. These are multiplicative inverses. So you're going to have x minus 9 equals 2 cubed, which is 8. And then add 9, you get x equals 17. And then letter C, you want to isolate the power part. So it's 4 minus x to the 3/2 power equals 8. So to get rid of the 3/2, you're going to multiply exponentiate both sides to 2/3. So it's 4 minus x equals, this is the cube root of 8 and then squared. So the cube root of 8 is 2. 2 squared is 4. So x has to be 0. And you can check all these too and plug them in. Check them. Okay, extraneous solutions. An extraneous solution satisfies your work while you're doing the equation but does not work in the original equations. Extraneous solutions can arise when you raise both sides of an equation to a power. So check all possible solutions into the original equation. So what I'm going to do is I'm going to isolate the radicand. So this is going to be 2x plus 3. Then I'm going to square both sides. But look, this time you're squaring a binomial, so you have to FOIL it out. You have to do 2x plus 3 times 2x plus 3. Oops. Here, I'll get this back. So this is going to be x plus 2 equals, then this part FOILed out is 4x squared plus 12x plus 9. So now what you have a quadratic. So if I had access to a calculator, I would put this in my y1 and this in my y2 and see where they cross. Because when you do that, you won't see any extraneous solutions. You'll only see the one that works. But I'm going to do this by hand, so I'm going to do one side equal to 0. Then I'm going to either do the quadratic formula, but remember first I'm going to try to see if this factors. So I do factors of 28 that add up to 11, and that's 4 and 7. So I'm going to write 0 equals 4x squared, and instead of writing 11x, I'm going to write plus 7x plus 4x plus 7. Factor by grouping, and you're going to have the result will be 4x plus 7 times x plus 1. Use the zero product property and set each one of these equal to 0. So x equals negative 7/4 and x equals negative 1. Okay, so you have to plug these in and see if they both work. So if you plug in negative 1 into the original problem, it works. But when you plug in negative 7/4 for x on both sides of the equation, it doesn't work. So x equals negative 7/4 is not a solution. It's called an extraneous solution. So the only solution that is x equals negative 1. So you can, to show your work, you can box x equals negative 1 and cross off the one that's not a solution and write extraneous. Okay, so B, I'm going to square both sides, and I'm going to end up foiling it out. So I have 2x minus 1 equals x squared minus 16x plus 64. I'm going to get one side equal to 0. And then after this, you can do what's comfortable with you. You could solve by factoring, or, well, let's check to see if it's factors. Or if you can't factor it, do quadratic formula. So I do factors of 65 that add up to negative 18, and that's going to be negative 13, negative 5. So this factors into x minus 13, x minus 5. So that means using the zero product property, x equals 13 and 5. So when I plug this in, 5 doesn't work, but 13 does. So 5 is an extraneous solution. And then letter C, I add 3x to each side. Then I square both sides. I'm squaring it because that gets rid of the 1/2. So this turns into 5x plus 4 equals, be careful over here, this is 9x squared. Then I get one side equal to 0, and I try to factor it. So factors of negative 36 that add up to negative 5 are going to be negative 9x and positive 4x. So when you factor by grouping, it turns into 9x plus 4 and x minus 1. So use the zero product property, and you got x equals negative 4/9 and x equals 1. So when you plug them in, this doesn't work. This is extraneous, and this one works. Okay, so again, I'm going to get the radical on one side. So I'm going to add this part to the other side. So I have x plus 1 to the 2/3 equals 9x plus 1 to the 1/3. Now, if I want to get rid of, the I want to cube both sides because that's going to get rid of these right here. Oops, I didn't mean to do that. I want to cube both sides. That's going to get rid of our exponent here, our denominator. Watch what happens if I cube both sides. This cancel out, so you'll have 9x plus 1. These 3's cancel out, and you're going to be left with x plus 1 squared. So the roots part canceled out, so you can multiply the denominator, multiply both sides by the denominator. Or if they had, if they had different denominators, what if one was like 2/3 and the other one was 1/4? To get rid of it, you'd want to clear the fractions. You'd multiply both sides. You'd exponentiate both sides to the power of 12 because that would clear both things off. So I'm going to FOIL this part out. So it's x squared plus 2x plus 1 equals 9x plus 1. Get one side equal to 0. The ones will cancel out. So I'll have x squared minus 7x equals 0. This one I can solve by, I'm going to fix that again. This one I can solve by doing the greatest common factor and factor out an x. So I'll use the zero product property and set each one of these equal to 0. So x equals 0, x equals 7. And then you want to check, and they both work. And then the last one, to get rid of the cube root, you're going to cube both sides. So on the right hand side, you're left with 16x plus 44. And on the left hand side, you're left with 4x plus 3 squared. So you FOIL this out. Perfect square trinomial here. Get one side equal to 0. And perhaps this is factorable right here, but can't think of factors of 16 times negative 35. That up to 8. So when I can't do that, I always rely on the quadratic formula. So this is my A, this is my B, and this is my C. So when I plug it in, I get negative 8 plus or minus the square root of 64 minus 16 times, or 4AC, I did that in different order, all over 2A, which is 32. So negative 8 plus or minus the square root of 2304 all over 32. So I get two answers. X equals 1.25, which is 5/4, and x equals negative 1.75. I guess if I could leave this as a decimal. And both of those work.